The only kind of compounds you've learned how to name are binary and ternary. You learned binary, ionic, and covalent, but you only know ternary ionic compounds. What ternary means is it looks like it's got three parts, but really it's sort of a binary compound. So really you only know how to name binary stuff. First we're going to start out looking at some names, writing formulas for them, trying to decide is it binary, is it ternary, what's the formula. Then we'll move on to looking at some formulas and trying to name those. The first thing you do is you read both of the parts. So we've got copper and chloride. So the reason I had you guys do all the ion quizzes where I said, what's the chloride ion? Is because I wanted you to realize polyatomic ions like these most of the time end in the letters Te. But monatomic ions, like things off the periodic table, they end in De when they're in a compound. If we see chloride, that means I don't have any other elements but chlorine in that compound. And then copper's symbol is Cu. Copper is one of those transition metals. We have no idea what its charge is until someone tells us. The way those people are telling us is with this Roman numeral. This particular version of copper chose to become +2. Chlorine is here in the 7th column, means it's going to gain 1 electron and it's going to be -1. Because these are ionic compounds, they always have to have their charges add up to 0. +2 minus 1, no, that does not add up to 0. We need another chlorine to make that happen. This is not a chemical formula. This is stuff that you will eventually be awesome enough to do in your head. For right now, it's here where we can see it. We needed 1 copper and we needed 2 chlorines. This is our chemical formula. There aren't any charges in it because we used the charges. They now add up to 0. The only numbers in it are the subscripts telling us we needed 2 chlorines and the invisible subscript of 1 saying we needed 1 copper. The next one is lithium acetate. Well, look, there's that Te. That means it's not an element. You could look on here all day, and I've had kids do that, looking for acetate. You're not going to find it. Flip this paper over. There's acetate. It's C2H3O2 with a -1 charge. C2H3O2 -1. Lithium, right here, first column, Li +1. This is one of those where we got lucky. +1 and -1 already add up to 0, so to make our formula, all we have to do is rewrite exactly this, but without the charges. Li, C2, H3O2. No charges, but all those subscripts stayed because they were part of acetate. In order to have acetate, we had to have 2 carbons, 3 hydrogens, and 2 oxygens. I'm not going to do all these because that would bore you to tears. What I'm going to do is go through and point out when we would use a polyatomic ion and when it's a monatomic ion, and then I'll make sure and hit a couple of them that require some interesting things. This one says nitride with a De. That means it's just this, the nitrogen ion. This one is a tricky one. It says hydroxide. It ends in De, so you're thinking, oh, it's an element. Well, you're not going to find hydroxygen on here anywhere. This is one of the exceptions that is hydrogen and oxygen. The name is reversed of the way we write the symbol. We do not write HO in chemistry. No, it's OH. We look on the list. Hydroxide is -1. Sulfate. It's got a Te. That means it's on this list. Sulfate is SO4, -2. Hydroxide again. Nitrite has a Te. That means it's one of these guys, NO2, -1. Chlorite ends in Te. ClO2, -1. Chloride, no, that's just the element, Cl, -1. Oxide is just O, -2. Carbonate, Te, means it's CO3, -2. Iodide with just a De means I, -1. Now I want to make sure and do one of these that requires some interesting things. So let's do beryllium hydroxide. Beryllium is Be. It's in the second column, so it's got a +2 charge. In order to make this thing add up to 0, we have to put another hydroxide ion in. So how do we say that we needed 1 beryllium and 2 hydroxides? We don't want to write OH all over again. We don't want to put O2H2 because that's not what the hydroxide ion is. It's not O2H2. We have to put a 2 and then put parentheses around the whole hydroxide ion saying I want 2 of that thing in the parentheses. This one is very similar. Lead, Roman numeral 4, is going to be Pb plus 4. Chlorite is -1. We need a total of 4 of these to make it become the equal charge to that. So we would write Pb, parentheses, ClO2, close parentheses, and I'm running out of room, but I'm going to put a 4 right there.